So my dear student, welcome you all. Today I am going to explain how the follower's motion it will be classified. So many of you will get confusion about the types of followers and types of followers motion. Okay, so types or classification of follower, that is different. So generally that will be classified based upon the shape or based upon the motion or the based upon the line of path. Okay, but here this follows motion having classification. So first one, it will be simple harmonic motion. So in short we call as SHM. So even in the examination sometimes it will be written as a SHM motion. And the second one is uniform acceleration and uniform retardation. And the third one is uniform velocity the last one is cycloidal motion. So you have to check your syllabus, what are the types of followers motion is applicable in your syllabus. Okay, if it is mentioned only about the study about the different types of followers motion, then you have to cover all four, and if specifically mention any one or two, three, so it can be mentioned. Okay, so these are the four types of followers motion. Okay, now so first today we will discuss about the simple harmonic motion. Okay, so in the question it will be mentioned like there is a line of stroke, that is mentioned as S. Line of stroke that we also called as size of the follower. Okay, generally in this problem I will explain how to draw the displacement diagram and what will be the values that will be given in the question and how you can understand that question. Okay, so different varieties of problems and what are the values you have to convert, and these things I will explain. Okay, so basically the size of the follower or the lift it will be mentioned. Okay, so lift is nothing but it is the size of the follower. It will be given in millimeter. Okay, remember the values will be given in millimeter. That is called the size of the follower. Okay, or the length of the follower you can say. Next it will be given the four stages. It will be one, it will be like outstroke. Okay, sometimes it is also called as like ascent. Okay, or it also called as rise. So all the varieties of problems I am telling in this. Okay, you should not get confused. Sometimes in the question it can be written as outstroke, sometimes ascent or rise. So this is called outstroke. Okay, so it will be written theta naught. And next there is a dwell. Okay, dwell is nothing but it is a rest. Dwell is nothing but rest or constant you can say. Okay, it means their velocity and acceleration will be constant. So that is we can say theta r. Okay, rest. Next another return stroke. Return stroke or descent you can say. So here rise, then it is return, rise, or down, anything you can say, right? Opposite word of rise. Then it will be return stroke, right? You can say descent or again return you can write to. Then after that again there is a dwell or rest. Okay, so it will be contained having four stages like outstroke, dwell, return, again dwell. So totally the okay, so displacement, first you have to draw the displacement diagram. So displacement diagram is nothing but we have to construct one rectangle first. Okay, that is called the displacement diagram or displacement graph we can say. Okay, so first there is an y-axis and there will be x-axis like this. Okay, just a minute. So I have to take some of the applications, like to take the scales. Yeah. Now so say the size of the stroke is given as 40 mm. Let us assume the values is given as 40 mm. Okay, that is yes, and total angle theta will be 360 degree of the cam rotation, and in that out stroke let us assume 30 degree is given, again dwell is given for 30 degree, and return stroke is given as 60 degree, and remaining del. Okay, so 60 60 total 60 360, in that we got 180. Okay, remaining will be 180. Okay, if you add these three, how much it will be? It will get 180. So remaining it will be well as 180. So adding all these you have to get as 360 degree, right? So first you have to draw and the x-axis. Okay, now this I am getting. Okay. Okay, like this you have to construct first a rectangular shape. So this y-axis it will be the total length, say s, or the size of the stroke. Okay, the length of the stroke, that is, for example, it is given 40 mm in this. Take the actual scale. Okay, so scale you have to mention always. Okay, whatever the suitable scale you have to write down. For example, suitable scale is nothing but, okay, so here what will be the suitable scale? For example, for x-axis and y-axis. Okay, so y-axis you can take the actual one. Okay, where 10 mm is equal to, you can say 10 mm. Okay, no changes in the vertical axis, because 40 mm you can draw easily in the y axis, but whereas you have to draw this as total 360 degree. Okay, this as you have to convert into 360 degree, but here it is given as 30 degree, you cannot draw 360 mm. Okay, so you have to reduce the scale. So I will say where 10 mm is equal to 30 degree, I will say, right? Okay, or you can say 10 mm is equal to 20 degree or 30 degree. Okay, anything you can say, 30 degree. Okay, 10 mm is equal to 30 degree you can write. Now how it will change? For example, it is mentioned that there is a outstroke as 30 degree. It means you have to take this as 10 mm and you have to write actual as 30 degree. Okay, you no need to mention 10 mm here. Directly you can write 30 degree and from that point just drag upward. Okay, so again one more block is created. Remaining dwell is 30 degree. So that is also you have to take as 10 degree, 10 mm and draw one vertical line. So this is for dwell. Okay, this is outstroke, and again return stroke is 60. So 60 means you have taken 10 mm for 30 degree. It means 60 degree you have to take 20 mm. Okay, so this will be 20 mm in actual, but you have to represent as 60 degree here, right? So whatever the remaining it will be there, that is 180 degree, whatever the scale you have to convert it. It means 30 degree you have taken, so 30 by 180 by 30 you have to make it. So you are getting 60 mm. Okay, 60 mm you have to take it to complete the total 360 degree. Okay, after that, here this is the first block. I will explain how to draw the curves in the outstroke. Okay, so first whatever the total length is there, that midpoint you have to take. Okay, for this it is 30, it is 40 mm, so midpoint will be 20. So from that, take this the center and draw a semicircle from outside. Okay, so now here this semicircle you have to divide into number of even equal parts. Remember it should be even. You can take 4, you can take 8, you can take 6. So like that you have to divide. Okay, now say you want to divide into 6 parts. Say this is 6 part means total 180 by 60. Okay, means at each angle there will be 30 degree, next 60, then 36, again 30. So 1, 2, 3, 4. So 0, 1, 2, 3. Just wait. So first one you have to drag to 30 degree, next 60 degree, next 90 degree, then again 120, next 180, then this one. Okay, so 0, 1, 2, 3, 4, 5, 6. Okay, we have divided like that. First one is 30 degree, next 60 degree, third 90 degree. After that again 120, 150, 180. Okay, we have divided like that. In the horizontal axis also, whatever the distance we have, say it is 10 mm. 10 mm should be divided into same number of equal parts, say 6. 10 by 6 you have to make it. So whatever the values you are getting, okay, so same thing you have to divide. Some it will be in division point, like it may be 0.5 something. So each division you have to divide 1, 2, 3, 4, 5, 6. Okay, whatever the value you are getting, same thing you have to divide. Now same point you have to drag to the upside. With the scale you have to make it, right, like this. After that, from all these points just draw a horizontal line. 1, 2, and from the 3, now from the 4, from the 5, and anyhow 6 set in the same vertical line. So here you can find, again you have to write all this division as 1, 2, 3, 4, 5, 6 at the end. So 1, 1 are intersecting at this point. Okay, so 1, 1 where it is intersecting at this point, this point. So 2 2 intersecting at here, 3 3 intersecting here, 4 4 are intersecting here, 5 5 intersecting here, 6 6 is intersecting here. Now take a curve so that it will connect all the points. Okay, use the blue color so that it can connect a spline type of curve. Okay, now after that again this is well, draw a horizontal or constant line here. So remaining again, if you draw the lines up to here, so the same curve and same procedure you have to follow, and it will get to the same curve at the down. Okay, now from here again you have to make a constant line up to the end. So this is the curve where the piston or where the follower it is reciprocating. This is the graph it indicates. Okay, so this is the angular rotation and this is the lift where follower can take. And here, okay, so in this way you have to draw the displacement diagram. So in the next video I will explain how to draw the cam profile. Thank you.